All right, guys, this is lesson 17, and we're dealing with inverses again. Okay, so remember last time, you guys, if they gave us a table of values and we had the x's and the y's, how did we find the table for the inverse? What did we do? We switched them, right? So that's what we're going to do on a graph. We're basically going to do the same thing. So look at this right here. So this pink graph right here, you guys, is the original graph. And then I take this line right here, y equals x, and I fold the pink across the red. And if the pink was wet paint, then like this part would go here, this close part would go there, the far away would go there. They all hit in the same spot. And if you fold it across, it's going to go right there where it's green. So it's reflected across this line right here, y equals x. Who says I understand that? Okay, great. Okay, so here's a graph. Find the inverse. I'm going to show you two different ways to do this. Okay, one way I like, and then if you get confused on that, then we got a plan B. Okay, first thing I want you to do is I want you to draw in the line y equals x. That is always going to be the line of reflection. The next thing I want you to do is this. Take your pencil, and do you see where the graph that's there hits the red? Put a dot right there, because my inverse is definitely going to hit there as well. They all three hit at the same spot. Okay. Now, what I'm about to show you is like a little bit of a rough way to do it, I guess, non-mathematical, but it's totally easy and it totally works. So it's how I teach it. When I talk about a diagonal, I'm talking about here's a box right here, and that's a diagonal. If I say half a diagonal, then I'm talking about half of the length of a diagonal. Who says I understand what you said? Okay, now look at this. See this point right here? When you fold it across, it's going to come over. Oops, didn't mean to erase that. So this is there. Okay, when I fold this guy right here, he's going to come across the other way, right? So the distance from this point to that line is half diagonal. So go half a diagonal, and the next point is going to be right there. Okay, look at this point. It's a half a diagonal away from that line. Continue on the same line and go the same distance, which is a half a diagonal, and that's the point. Look at this other one. Okay, it's a half a diagonal away, so I'm going to go half a diagonal the other direction, and that's it. Now, see all those little lines I've drawn? We really can't draw those lines. I mean, they really shouldn't be there. If you do them, you can just erase it. But then basically all you do, guys, is just play dot to dots here, and there's your inverse. That's all you do. Let's label it F inverse of x, and we're done. Okay, who says I completely 100% understood that? Do your hand in the air so I can see. Okay, now I want to show you something else. See the black line? I want to do a table for that line that is f of x. So call it f of x, and we're going to make a table of values. So see this point right here? You go left 2 and down 1, so that's -2, -1. This point right here, you go left 1, don't go up or down. So that's -1, 0. And then this point right here, you go right 2 and up 1. So that's the ordered pair 2, 1. Now, if I wanted to do a table for the inverse, I would just switch those. So I would have -1, -2, 0, -1, and 1, 2. And now if I plot those points, you guys, if I go left 1 and down 2, do you see how that's the point on my inverse? And then don't go right or left, but go down 1. And then right 1 and up 2. And so you can get those points either way. If I understand the diagonal thing and I got it right, I don't have to go through all of that process. I was just trying to show you a plan B. Who says I understand both things you just showed? Okay. Sometimes the graph gets a little complicated, so that's why I show you that. Okay. Okay, so graph this and its inverse, find the domain, find the range, blah, blah, blah. Okay, so I'm going to give you an order. Okay, so over here, the first thing I always want you to do is to graph the original. Okay, so everybody write down y equals 2x minus 4. This is a line. the y-intercept is down 4. It's shifted down 4. And the slope is 2 over 1. So from that point, you go up 2 and right 1, up 2 and right 1, up 2, right 1, up 2, right 1. I'm going to draw that in. And then I'm going to label it f of x, because I'm going to have multiple graphs on my axis, so I want to clearly label, okay? The second thing you're going to do is you're going to find the domain and the range. Everybody look at that graph. Domain is x, start at the left, travel to the right. Everybody tell me what the domain is. Go ahead and tell me, come on. Everything. Yeah, all real numbers. I don't think we've talked about this symbol. Do like an 11 and then turn it into an R. That's the symbol for all real numbers. Okay, let's do range. Everybody look right here. We look right here. Range is y. Okay, so you make it perpendicular, start low, you move up. Everybody in the room, all people in this room, what's the range? All real numbers. Thank you so much for answering. All real numbers. The third thing I want you to do is to find the domain of the inverse and the range of the inverse. Well, I don't even have a graph, nor do I have an equation. So how am I expecting you to find those? Do you remember? Yeah, they switch, right? Remember the little thing? So draw an arrow from here to there and from there to there, and they switch. Well, they're all real numbers, okay? The fourth thing I want you to do is to graph the inverse. I don't even have an equation for the inverse. You don't have to. You can do it from the graph, guys. So plot that line, y equals x. Looks like that. Okay, then go to the place where the purple hits the red and put a dot right there. And now let's do the diagonal thing, guys. Look at this purple dot. Half diagonal the other side. This dot right here is a full diagonal, full diagonal. This one's a diagonal and a half, diagonal and a half. I feel like that's enough points. I mean, I think I can get a really accurate graph from that. Draw my line, label it f to the negative first of x, draw an arrow at both ends, and now I have to come up with the equation. Okay, here's how you find the equation. Look at these steps right here. Right there. Switch the x and y, solve for y, and label it the inverse. That's all you have to do. So look at that equation that we have, you guys. It's y equals 2x minus 4. Everybody write down x equals 2y minus 4. So inverses, you guys are always switch the x and y's. That's all we've been doing, right? Let's solve that for y. So the 4 is going to come over to the right and become a positive. So I have 2y equals x plus 4. So I did 2 steps in one. I pulled the 4 over to the left, and then I swapped my right and my left. If that confuses you, then don't take that many steps in one. The last step is to divide by 2, and I'm going to divide everything separately by 2. And then I get y equals, but I'm actually going to call it f inverse of x equals. And then x over 2 is just 1/2 x. And then the reason it's 1/2, you guys, is because in front of the x is a 1. So you just push the number forward and you get 1/2 x. And then 4 over 2 is a 2. And that's the equation for my inverse. And I'm done.
So
okay, yes.
Like at the very beginning, we have x equals 2y minus 4. How do you get a positive 4 if it's still on the right side?
Okay, so let me just do this one step at a time instead of 2. So if you take the 4 over, it's going to come that way. Mm-hmm. So then you have x plus 4 equals 2y, which is the same thing I have right there. Okay. I just switched it. Okay, you're welcome. Okay, who says I totally get that? Raise your hand, let me see. That's all we're going to do. We're just going to do it a couple more times, literally 2 more times, and then one little example, and then we're done. That's it, okay? So question 3 looks weird, okay? Everybody write down y equals x minus 3, and then take the x and take the minus 3 and divide each of those separately by 3. So now I have y equals, if I want to just put the x right there, guys, and I want a number out in front of the x, what would that number be? Can you tell me? It would be 1/3. Yes, 1/3 x minus 1. Okay. Oh, go back to the steps. I think I forgot the last step. So step number 5 is find the equation for the inverse. Follow those steps and it'll be easy, okay? So step number 1, graph the inverse. Okay, so let's do that, you guys. Go down 1, make a dot. The slope is 1/3. So up 1, right 3. You could also go back to that dot, guys, and reverse them both, down 1 and left 3. And I'm going to make it really long, and I'm going to draw arrows at both ends. And I'm also going to label it f of x. Now let's start making some summaries, okay? Will everybody look right here for a second? Will you look right here? Okay. I hope you can tell that I really care if you are successful in my class. If someone doesn't do well, then it bums me out because I feel like I failed you and I never want to fail you, okay? So I feel like last time you were in class, I feel like you thought I was angry. And I wasn't really angry. I was just kind of frustrated because I would ask you guys a question and you weren't communicating with me. So then I had no idea if we were connecting. So I really want you to answer. I want you this to just be casual and I want you to talk. But if you sit there and you don't say anything to me, then you're not doing my part, your part of you being successful and us communicating, okay? So just make sure that you talk to me, okay? Because I got to do my job. And if you don't tell me if I'm doing my job, then I don't know, okay? All right, so I just graphed that. Let's start making some summaries. You guys are going to come up with the summaries. If nobody speaks up, then we just won't have a summary because I'm not going to do it, okay? Look at the line. The one before this was also a line. Look at that line, and I want you to figure out what the domain is. So here's domain. Make it perpendicular. Start at the left and move to the right. Everybody in the room, what's the domain? All real numbers. If we have a line, and it's just a regular line, like some kind of a slant, I'm not talking about vertical, I'm not talking about horizontal, I'm also not talking about a line that might have an open circle in it. I just mean like a regular line. What do you think the domain is always going to be? Imagine it. What do you think it would be? All real numbers. Yeah. Look at the range. Can anybody give me some kind of a generalization about a regular line, the range of that? Can you tell me? All real numbers. So now we can just kind of remember that, right? So if these are all real numbers, then the other ones are also going to be all real numbers. Without looking at the steps that I gave you, do you remember the next thing we did? Did we do the equation or did we do the graph? We did the graph. Good. And when we do the graph, I always want you to start, you guys, with that line y equals x. So it looks like that. Okay. Now let's do the diagonal step. The first dot, if I were you, that I would always make is the point right where those things cross, because mine's definitely going to touch that. See this point right here? It's a half diagonal, half diagonal. Right here, diagonal and a half, diagonal and a half. That's enough points. I can draw a line with those, connect my dots, and there's my inverse. Does it look like when you take the purple line and fold it across the red, does it look like it would go to the black? Somebody tell me that. Does it look like it? Pick up your paper right now, okay? Grab your paper, and I want you to fold it. Literally, I want you to fold that paper. So fold your paper. Can I borrow this? So look right here. This is what I want you to do. I want you to take it, and I want you to literally fold it right across that y equals x, the best you can get. And then I want you to watch what happens. If you fold it, like get your head really in there, would they lie on top of each other? What's the answer to the question, everybody? It would, right? That's because they're inverses. That's what inverses do. Okay, so the answer to the question is yes, they would. Okay, everybody write down. See this y equals 1/3 x minus 1? Let's write it as x equals 1/3 y plus 1. Now I'm trying to solve for y. So I'm going to move my 1 over to the left. So I have x minus 1 equals 1/3 y. I want to solve it for y. I got to get rid of the 1/3. Tell me how to get rid of the 1/3. Multiply by 3. How many times do I have to multiply by 3 in this problem? It's actually 3 times. Look, 1 here, 1 for the 1, and 1 for the x. So there's 3 terms, so I have to do all those by 3. So now the 3's cancel, and I have f inverse of x is equal to 3 times x is 3x, 3 minus 1 is a negative 3, and that's it. Is there a way, I did something wrong. Oh, I know what I did wrong. I'm like, that doesn't match. Can anybody see what I did? Thanks. It is, because see this 1/3 x minus 1? So when I wrote it here, I wrote it as 1/3 x minus 1, or plus 1. So that should be a minus. So when I pull it over, it's a plus. So therefore, this is a plus. Thank you, honey. And you know how I figured that out? Look at that line, guys, y equals 3x plus 3. Look right here. Take your pencil and graph it. Go up 3, make a dot. Up 3, right 1, down 3, left 1. It should lie right on top of the inverse. So it's a quick check. So I just caught my mistake because I was going to make that connection with you, and I caught my error. That's perfect. That's what you guys should do, okay? Okay, here we go with example 4, okay? Everybody write down y equals negative x plus 3. So go up 3, make a dot. The slope is a negative 1 over 1. So I go up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1. You guys really do lots and lots of dots and make it really, really long. And let's label that f of x. Yes.
Shouldn't it be a negative 1?
Yes. Thank you. You just keep correcting me over and over today. Would you stop? No, I'm just teasing. It's supposed to be down 1 and right 1. Down 1, right 1, down 1, right 1, down 1, right 1. Up 1, left 1, up 1, left 1. Thank you so much. I did that error on purpose to see if you guys were watching. Okay, so label that f of x. Everybody tell me domain of that line right there. Tell me what it is.
All reals.
Everything. How about range? All reals. So then these flip-flop. What do I do now? Equation or graph? Graph, right? So draw that in. This is really weird. Right? If I take this guy, half diagonal, it just goes there. If I take this guy, diagonal and a half, diagonal and a half. The inverse and the function, how did the graphs compare? It's the same. It's kind of weird, right? How do you show that the inverse is there? Do a double arrow and then label it the inverse. And I think I would probably put an and symbol. Now, watch what's going to happen with the equation. What's the equation for the inverse going to be, everybody? The equation of the given, right? Let's do it. So you have x equals negative y plus 3. Pull your 3 over. So you have x minus 3 equals negative y. Change the signs, and you have the inverse is negative x plus 3. Well, that's what I started with. So can an equation be an inverse of itself? Yes. And once you realized that they lie right on top of each other, did I really have to go through the work of showing that they were the same? No, you didn't. Yes, honey?
Why wouldn't you make, since it's like a negative, why wouldn't you make like the parent line the other way?
The line of reflection, the red line, it's always the same.
Okay.
Always the same. Okay? Okay. Question 5. Explain how you could graph an inverse without finding the equation of the inverse. Okay? Well, we've done that 3 times. Okay? So I'm going to say graph the line what's the line of reflection? Don't look at your notes. What is that equation? Y equals x. So graph the line y equals x, okay? And then say reflect the original graph over y equals x. That's all you have to do. Okay? Who says I'm good? I get this? Great. Okay, we are done. Okay. You know what? There's one more question. There are actually two more questions that I want to do for you off of these quiz corrections. So will you guys help me pass these out? Listen for your name, okay? And I'm actually going to do two more problems off of this. Okay? If you need it.
Shall we?
Yes. It is not. Thank you for saying that. I think it is not. But you guys are just such amazing people. Let's see.